Hello, everyone. Welcome to another inspiring session of our modulyss Talks. I'm Morgan, your host, and I'm thrilled to have you join us. If this is your first time attending, modulyss Talks is all about educating and informing design industries professionals like you. We explore the latest insights, trends, and innovations to help you elevate your projects and expand your expertise, and this all during your lunch break. Today, we'll be discussing how sustainable design isn't just about aesthetics, it's about data and impact. From smart material comparisons and carbon neutral innovations to digital tools, discover how the right choices can actively drive your carbon targets. Leading this modulyss talk is Sunita Van Heers, sustainability expert, founder of sustainability consultancy agency SuReal, and author of the SuReal Guide Towards Net Zero Carbon Buildings. Sunita brings a sharp perspective on the latest tools and trends, making your projects a powerful part of sustainable architecture. If you have any questions, put them in the Q&A box and we'll answer them after the talk. So without further ado, Sunita, the floor is yours.
Thank you. Thank you so much. And welcome to everybody who has joined. It's always weird to be speaking in front of a screen. But I'm happy to guide you through sustainability and tools. Um, I'm not going to give an entire introduction about the reason why we need to do it. I guess you all know the reason behind our changing world. Um, but I do want to link it towards there's also a regulatory change. And this change is also thanks to the people, you and I, who went on the streets and are fighting for it. And this change was also as a regulatory point of view, and it's only going to become even more sharp with regard to carbon and especially carbon in materials. Um, so this question if the environmental impact is already a part of your decision or decision making when you're choosing for materials should be a yes, or should be yes. In the near future, I will include it. Um, Without going into detail of all of these labels and frameworks and regulations, just to give as a quick anecdote that actually sustainability or sustainable development was born in officially was born in 1987, and as of then we have BREEAM, Cradle to Cradle, LEED, GMB, lots and lots of rules and frameworks and guidelines that actually already looked towards carbon in materials or flexibility or adaptability. So this is really not something that is new. It is something that has been existing. But what did really accelerate it was the European Green Deal in 2019. Here, really, the European Union altogether said for us, sustainability goes much further than just energy efficiency. It's also about the environmental impacts that we have from our materials and the depletion of our raw materials. So circularity became one of the really six major important topics of sustainability in the EU. And then quickly afterwards, actually, even for example, in France, they had a maximum level of carbon in materials. Some other regulations changed, omnibus, but the main important part is 2030, we're still wanting to go to our carbon reduction of 55%, and 2050, really going towards carbon neutrality. Now, one major regulatory force, which is also there, is the EPBD. And the EPBD, it goes much further than just energy. As of now, how it is voted, it also for renovation projects and new build, it will also focus largely on the global warming potential of your materials. And as of 2027, all the member states must publish their roadmap for a life cycle global warming potential limits. For then, indeed, every member state as of 2030 having an obligation to do a global warming potential. So therefore, carbon in energy use, but also carbon in materials. So it's not just that we want it, it's becoming legislation. So therefore, this session just became even more interesting. But then how can we measure it? Because it's one thing saying, okay, you need to do it, you need to pay attention to it, but how are you going to actually measure it, and what kind of tools or data could be used for this? So one of the major elements here, you might already know and do this, is the life cycle analysis. And this is really how you can calculate for an entire building the impact on environmental aspects of the materials used and your energy used. And so this life cycle assessment, it's a calculation that is done through official European rules how to calculate it. And it's split up into several phases. You have your first phase, which is of course your product stage. So, okay, how much energy is linked to extracting raw materials? How much energy, carbon, acidification, other environmental credits is used for the transportation, then manufacturing, but then also during your construction process stage, what is the water use, the energy use, even transport indeed there, construction practices. But then also during the usage, because you can have, for example, a material which has a very low intensity in manufacturing, but only has a lifespan of 10 years. So therefore, after 10 years, you will need to replace it. So you will restart your manufacturing from the start. And then, of course, you have end of life stage, because there also you have environmental impact, you have carbon, which goes to waste processing, deconstruction. There is an interesting phase, that's the phase D that we call it. And this is really your benefits for reusing or recovery or recycling potential. Officially, this D is not included in the life cycle analysis calculation. We can have more discussions on that afterwards, but for the time being, we don't have time for that. And what comes out of it then? A lot of data. And this data should be used to further guide your design or your choices. So you see here, for example, okay, a lifespan of 60 years, your square meters, your emissions, but then you can also have a split up of operational carbon, embodied carbon, and most importantly, also split up between all the different kind of materials. So for example, here you can see for this specific project, 35% was in the internal partitions, floor systems, stairs, 23% in the structure, finishings 27, and here you can even see a further split up. And what does that say? We like to call it, or we like to use the 80-20 principle. It's not a SuReal thing that we invented, but we always use it. Focus on the 80-20. Don't go necessarily like, look, your roof is already quite optimized. Focus on where it has the biggest carbon intensity or biggest environmental intensity, and go look for alternatives here. And what could these alternatives look like? I know you can't see a lot, but let me just guide you through it. So we've seen that insulation, it was one big part, or the system as such. So you have insulation, wall structure, wall refurbishments. And then we just look at a lot of different opportunities, bricks, stones, lightweight sandwich panels. We look towards the thicknesses, the U values, the embodied carbon, environmental impacts, carbon storage that you could even have. But what a lot of the times is not done is you should always look at the life cycle assessment or impact together with a lot of other criteria, such as fire resistancy, bio-based potential, moisture buffering, demountability, maintenance, resilience, thickness. So it's really, if you map all of these things, if you put all the data there, and it can be quantitative, it can be qualitative, that you can really go towards the best solution for this project together with the entire team. So how does it work? Is actually you have EPDs per material. So for your bricks, you have an EPD. For your paint, you have an EPD. And then for indeed the cement, you have an EPD. You have the quantity, and you put all of that. So even if you have like attachment hooks for insulation or attachments or for something else, for your bricks. All the little details, they should actually go into this calculation, into your LCA. And there are two main tools. So in Belgium, you have the totem tool. And then we use a lot the one-click LCA tool because it gives you the opportunity to really encode very much into detail. And then these tools, they give you a final life cycle assessment of your building. So when we trickle it back, actually the environmental product declaration, so your EPDs per material, actually bring a lot of value because they store a lot, because it's with these elements that you go towards your final rating on your building. And when we're talking about the EPDs, like this result, doing this entire study will become then mandatory for all member states as of 2030. And a lot of member states already have it in their plans to have it much sooner. So you will perform this analysis and therefore really digging through the full EPD of a material is very valuable. One of the checks that should definitely be done is to really see that all of the different stages has been filled in and has been calculated. And then you can start comparing materials to materials to really go towards the final end. So if we link it to the first image I showed about like international sustainability framework certifications, if you go actually to the most used sustainability certifications for buildings, DGNB is a German system, BREEAM comes from UK, broadly used internationally. LEED is more the American part, but also internationally used. Here is actually a requirement to use an LCA to calculate really all of their environmental impacts of the entire building, so every layer. But then also for the EU taxonomy point of view, it is really essential to perform it to be actually EU taxonomy aligned. So it's not something that is only in the near future. It is really already a useful tool as of today. But then, of course, why measure if you're not going to do something with it? There are some guidance tools which we can definitely use to reduce the environmental impact of our buildings. So there's a decision-making period that everybody should debate to. It's of course first preserve. As petite anecdote, we're working on this very big project, about 80,000 square meters, existing building, and we could top off with 7 new floors on a 6 floors existing building. So everybody assumed, okay, we're just gonna tear down the building and make a new building because up topping 7 floors on a 6 floors is impossible. But then we actually challenged the stability engineer, and they actually found out that the foundations and the structure was actually so well designed that we could just keep the 6 floors and then just opt up the new 7 floors without actually demolishing anything. And we're just putting some extra stability elements, pillars in the project. So preserving buildings as such or materials as such. Reducing. Already in reduction of the amount of materials. For example, I'm now sitting in a building brut chic. So it's where you keep the concrete appearance and then add some nice chic elements to it. So it's in a reflection already. How can we change a bit the way how we design, how we use materials, and try reducing already materials? That's should be an easy one, but sometimes not as easy as that. And then, of course, the reuse. So we have urban mining, which is really going into looking at actually all of the buildings as a mine, where when you come at a building, see what is valuable here in terms of aesthetics, in terms of carbon, and just reuse it into the same building or next building. Bio-based materials. Bio-based materials have a very low environmental impact. Are therefore more interesting or should be looked into. They do have some other characteristics with regard to, for example, fire safety, acoustics, etc. So it's always quite important to do this thorough check of all of the different factors that we need to take into account. And then, of course, we have recycled. For example, well, of course, if carpet tiles, you could actually indeed recycle it, and you can go towards a high percentage of recycled content. And then only really, if we looked at this entire pyramid, we should only go to new. Sounds easy, right? As an example, where is the most of the embodied carbon distribution stored? So we looked at all of the offices and residential buildings that we're working on, and at the moment we're working on about 150 buildings. So this should be already kind of a good comparison all over the world, but a lot in Europe, of course. There we can see that there's a bit difference, of course, between new construction and renovation. But so foundations are actually not that much, of course, here. But then indeed structure is always quite an important aspect. Facades, but this part, so the internal partitions, flooring systems, etc., and the finishings also has a quite big impact, because typically structure, well, you need structure, okay, and you have options, but it's not always possible to go to a wood solution or anything. So this actually has a quite valuable percentage that we can work and should work on. Just as a quick example for a project that we went quite far, we had the luxury of working with a very nice developer who we wanted to have that dialogue. It's in Brussels. It's an office building, a renovation of an existing office building. And there we worked on this embodied carbon reduction quite drastically. So really looking at all of the different layers and optimizing all of the different layers. So we really kept most of almost everything of the existing structure. And then we even kept most of the existing facade as well. And then put like a new outer facade on it. Definitely also worked on dismountability, a lot of bio-based materials, and some very nice reuse of materials. For example, all of the granite stones, even at the inside of the building, but also the outside, was all taken away, which is a really impressive kind of a setup to get it all out. And some of the examples is, okay, so at the reducing visible technical installations, that's already reducing materials. We have even reused indeed sanitary equipments, but also even like the design was made that we could keep all of the vertical circulations, and they were protected during the renovation. So really this reusing as such and adapting actually the design for it. But then for the glazing and the facade cladding, we couldn't use it as such. So we made a new granito for the ground floor finishes. And then of course, as you see here, really a lot of the structure was kept. And then indeed some parts of the facade cladding is cut and reused as a window shield. It's finished, by the way, the project. We also used so this recuperazzo is also used for the sink. We have bamboo even in the toilets, hemp blocks, lime placer. So we went quite far in it. But as another anecdote, how far this reuse potential can go on your materials. If somebody says, yeah, well, let's just focus on the energy part and not on the operational carbon and not that much on the materials. This was also quite a big project, and there we calculated that by reusing the carpets and the flooring system actually underneath it, so the high raised floor, it would actually be the equivalent of 13 years of operational carbon impact, which is huge actually. So there again, the importance of actually looking through it and looking for ways to reuse all of these elements. But there are also some other business models that actually facilitate this. So it is, as a designer, as an architect, to think about different ways of designing, different ways of using materials. But there are also some help aids when financially bio-based, the reused material is higher. For example, these are walls. They're dismountable walls. We have them here in the office. But they look at sort of a buyback formula. So actually the extra investment that you need to do to use this like this super dismountable reuse material. This extra investment, you actually take it back by having this cashback principle. At SuReal, we also written a book, I will show it also here, about all of the elements, about ideas about designing these net zero carbon buildings. And we're quite active in several R&D cases to look towards these new business models, and we call them SESCOs. So it's actually like a third party kind of investments of a circular solution. And in our latest research project that we did with other parties, the circular value index also arose. So this circular value index is kind of like an indication if your product, your solution, it has a high potential for a circular value, because we talk about circularity, reusing, but the value of your product should also be capitalized. So it's a mathematical calculation. It's a residual value over the cost of reuse times the risk. And actually in this project, we're together with financial institutions, investors, even research institutions, to actually even provide financing, so that actually even the financial part of the circular economy is taken care of. So really no question anymore if you should do it or not. A lot of solutions that we can provide actually. This was quite a fast, short introduction on it. There's definitely still time now for questions, which I'm happy to look at.
Thank you, Sunita, for this inspiring modulyss talk. And indeed, we still have some time for some questions. The first question is, what information do clients need to understand the real impact of their material choices?
Wait, could you repeat?
What information do clients need to understand the real impact of their material choices?
Well, I would definitely first go with it's understanding clients. What is the why of a client? Of course, regulation is a very important one. It's just the impact, the carbon impact, the environmental impact of material. Knowing it and reducing it will become law. It's already voted on a European level, so it will depend country by country when it is. So that's point one. It's coming. You can't actually change anything about it. Then, of course, it's also kind of like it could also even be a selling point, that you don't only, if it's, for example, to attract the tenants, or if it's in a competition phase for a public entity, it is really explaining them, look, operational carbon in your energy, we already optimize that so much, but as my example showed, by just reusing the carpet solution and your flooring, it's the same as 13 years of energy, use your energy bill. So it's really this level of responsibility taking, and that there's a lot of carbon included in it. And I would also say sometimes everybody thinks automatically it's more expensive, which it is not. It really depends on the building as such. For example, the project I showed, from the inside part, that was super expensive to take it down. But from the outer part, it was not expensive. So actually, next time, if we would redo the project, we would not do necessarily the internal part, but yes, the external. So it's really thinking from the start, what can we do? Is this a solution? Yes or not? And mapping it so that they also see that it's not necessarily, it doesn't cost more necessarily. And when it doesn't cost more and you have a large reduction in carbon impacts, why not do it?
Okay. And then the next question. On the slides, it says reusing the carpet would save 13 years of operational carbon impact. But which operational carbon impact, floor or total building?
No, no. So operational carbon is indeed the total operational carbon of the building. So it was an office building with an operational carbon, which is just the energy and water use of the building. And that had an amount quite low because it was already an optimized building. So indeed, if you now have a super energy intensive building, it would not be less. But so their energy bill or the carbon impact of using the energy of the building, that's times 13 was the carbon savings by reusing the carpets. I hope that gives an answer to the question.
And
But so it
then,
really depends on your project, of course. It needs to be calculated every time.
yeah, of course. And then another question, what are the biggest data gaps today that hinder reliable circularity assessments in construction or real estate?
So you have circularity, and circularity is very vast. Circularity is about depletion of raw materials, but it also goes into dismantleability possibilities, flexibility. So circularity, you don't have like one thing that you can calculate it. So the CVI, the circularity value indicator, is more to assess the value, money value, residual value of reusing a project. But I would say that indeed one step is already indeed that we have enough very thorough EPDs. Some EPDs are not fully filled in. It's only partial. Some databases, because there are not enough EPDs, we have like more general basic databases, but they just take like a whole bunch of different materials all together. So it's working on I would say the exact EPDs that everybody using the same European norms that were written out to calculate it all. And then in terms of circularity, the start would be more understanding what it all means, and understanding that indeed you cannot put it in one exact figure. For example, wood, like if you would use a CLT, it has a biogenic storage, so it can capture carbon. But if that wood is burned, the carbon is again released in the atmosphere. So it is too short to say that I have a carbon neutral or a negative building because I build in wood. You can only actually say that if you are 100% sure that that wood is not going to be burned. So it's this complexity that still needs to go a bit further. Yeah.
Okay, well, I think that's it for the time that we have for today.
Okay.
Thank you again, Sunita, for this inspiring talk and sharing your
Welcome.
expertise. And thank you for everyone for joining us today. This was the second part of our modulyss talks on carbon neutral architecture. The final part of this series will take place on December 3rd at the same time. So be sure to sign up for that one. It's on closing the carbon gap in commercial interiors with building performance analyst at Alfred Hull Monaghan Morris, Ella Smith. For this session, you'll receive a recorded version and the Q&A later via email. And if you want to stay up to date on the new modulyss talks and events, be sure to subscribe to our newsletter. So thank you so much for following along. And thank you, Sunita, for this inspiring talk. And yeah, see you next time.
Thank you, everybody.
Bye.
Nice day. Bye.
Bye.